Take number 16. No, I'm just kidding. Stoichiometry in the real world, basically known as limiting reactants, video number 8. Okay, guys? So here's what's happening. Limiting reactants is like this. You have 4 slices of bread, a jar of peanut butter, and a half a jar of jelly. What's going to run out first if you're making sandwiches? The bread. And it's limiting it. So what's going to be excess? What are we going to have left over? Jelly and peanut butter. How many sandwiches we're going to be able to make? Just 2. Okay, that's kind of the basis for limiting reactants. I want you to write this stuff down. Don't worry about this part right here at the very bottom. This one, no. Limiting reactant means everything's going to get used up in the reaction, and it determines the amount of product that we are going to produce. Okay, excess is added just to ensure that everything is completely used up in the reactant of the other ones. Okay, now here's what we need. Okay, so we need to make sure, again, that we have a balanced chemical equation. Here's the difference. We're going to have, for each reactant, we're going to calculate the amount of product formed using your railroad tracks. You're going to have two sets of railroad tracks. Okay, they're going to look exactly the same, except for we're going to have 2 givens. Okay, the smaller number indicates you're limiting a reactant and how much product we can make. That is the key. Okay, so here's our problem. We got 10 grams of zinc reacting with 20 grams of hydrochloric acid, HCl. Okay, how many grams of hydrogen are formed? That's what we're looking for. So we're going to set up some railroad tracks. I'm going to go do it on this next slide so I have room. So we had 10 grams of zinc. Okay, we are going to go to grams of hydrochloric acid. I'm sorry, hydrogen. So we're going to have another set of railroad tracks. Okay, this time we're going to have 20 grams of HCl, and we're still going to go grams of hydrogen. Okay, so in this thing, we're going to do still top to bottom grams of zinc to 1 mole of zinc, moles of zinc, and then we're going to have moles, that's the ZN, of hydrogen, and over here we're going to have moles of hydrogen, but you know that's 1. Okay, your 1 goes here. Let's do this one. We're going to have grams of HCl. You're going to have 1 mole of HCl, moles of HCl to moles of hydrogen. You notice I'm using H2. Oh, there's a 2 there. And moles of hydrogen. All right, so we need to fill in these things. I'm going to do the bottom one first. So we have 36.47 grams, and the ratio is going to be a 1:2 ratio. This is going to be a 2.02 for the molar mass. That one's done. I'll start here. It's 2.02. The mole ratio this time is 1:1 because we have a different substance. And the grams of zinc is 68. Just a second. All right, I'm going to scratch that because it's not 68. I just checked it. It's 65.38. 38 grams. Okay. So again, you're going to cross out what you don't need. Cross out the 1s. Cross out the grams. Cross out the moles of zinc, moles of hydrogen. Multiply what's on top. Divide by what's on bottom. And you get 10 times 2.02 divided by 65.38, which when you put it in your calculator, sorry about the lines, I don't know why it does that, it's going to be 0.308 grams of H2. Okay, down here, you're going to cross out your 1s. You're going to cross out your grams. You're going to cross out your moles of HCl, moles of H2. You do the math. It's going to be 20 times, that's a times, sorry, 2.02 divided by 36.47 divided by 2, which gives you a 0.50, I'm sorry, 554, sorry, 554 grams of H2. So when we're looking at limiting, which one is going to be the smallest one? Well, it's going to be this one right here. So this substance right here, the zinc, is going to be the limiting reactant. Okay? The hydrochloric acid is going to be the one in excess. Okay? The one in excess. Okay? So the most hydrogen that we could make, no matter how many times we try this with these numbers, 10 grams and 20 grams, we're only going to be able to produce 0.308 grams of hydrogen. Okay? If we had excess zinc and we started with 20 grams of hydrochloric acid, we could make 0.554 grams of hydrogen. But because we're putting it with 10 grams of zinc, all we can do is 0.38 grams of H2. Okay, key here, 2 railroad tracks. All right, come to class with questions. I'm sure you're going to have some, but I wanted to make this video short, so it's 6 minutes and 30 seconds. I'll see you tomorrow.